Now let's explain why this environment is so sensitive. Let's explain that first. If you look at these mountains, you will find that right at the top we've got volcanic rocks that came through crevices and cracks with volcanic motion, pushed up, and it mushroomed over the top. That's the dolerites. It's a very hard volcanic rock. They also call it Eysterklip because it's hard as iron. Under those dolerites, underneath it, is a layer of sandstone. That sandstone varies from 50 to 300 meters thick. The sandstone used to be sand, and the volcanics, the heat of the volcanics, melted the silica in the sand, and the pressure on top metamorphosed the sand into sandstone. Below the sandstone, much older, is a layer of siltstone, and even below that, a layer of mudstone. Now the mud and siltstone is sedimentary rocks that filtered under water conditions like mud, and that mud and the silt eventually turned into solid rock after long times, with all this pressure and weight from a sandstone and the dolerites on top of it. Now just look at the structure of this geological strata. The mudstone, the mud has got a high clay content, and the particles are very small, and it locks the water and it keeps the water together. The siltstone is even finer than mudstone. The particles are still smaller than mudstone, and that doesn't form a real clay when it gets wet, but it forms a 2 centimeter locking when the water comes on the top. The water doesn't filter through that 2 centimeters, and everything runs off, and we lose it. We've seen it yesterday with the rain, how that water just washes off and away, and we lose it out. In the same time, the siltstone, the particles, besides with that little bit wetness that it bonds only for that moment, that particles, because it's so small, it also runs with the water. So no infiltration, and further like dust, it goes with the water, wash it away. And you see that in the water coming down, like yesterday, it comes like red soup as it comes down, taking the sand with it. The sandstone higher up gives you an acidic soil of much larger particles, and the water infiltrates that quite quickly and very effectively, but it's acidic. So it gives you sour felt and less nutritious grasses on it normally. The dolerite gives you the best of all. That is a cherry on the cake. That gives you high nutritious soils, very good quality, but they're only right at the tops and here and there on little plate areas where you find them, and you'll see them as little pocket patches areas. And that little patches is not enough for the number of animals that used to be on this place. At the moment, we don't know yet how many animals is there. We will still have to do new counts again after it. But anyway, I am here doing now the resource evaluation first, so that we can measure and see what is the limitations that we've got and the potential that we've got.